let's look at a problem involving projectiles that are launched at an angle. This is practice E, page 101. This is number 1 in your text. In a scene in an action movie, a stuntman jumps from the top of one building to the top of another building 4 meters away. After a running start, he leaps at a velocity of 5 meters per second at an angle of 15 degrees with respect to the flat roof. Will he make it to the other roof, which is 2.5 meters shorter than the building he jumps from? Let's begin by drawing a picture of what's happening here. We've got a stuntman who's at the top of one building, so let's draw the top of that building. And he is jumping from that building at a velocity of 5.0 meters per second at an angle of 15 degrees. Okay, so we only know the resultant, we don't know the vertical and horizontal components yet. Now they're asking us, will he make it to another roof, which is 2.5 meters shorter than the building he jumps from? And they said that this other building is 4 meters away. So in order to survive this, he has to jump at least 4 meters, and he has to have jump at least that far out, and he has to be able to go down at least 2.5 at that point. We're going to start again the same way that we did with the last problem, and we're going to look at finding the time first. Okay, if you look at your formulas that are found on page 99 of your text, you'll find a variety of formulas that are used for projectiles launched at angles. Remember that the horizontal velocity is always going to be constant, okay, even in this case. And so my Vx is going to be constant, but in this case I have an angle going on, and so I'm going to be talking about just that horizontal component. Okay, that's constant. Right? We're not going to be talking specifically about the 5. We're going to be looking at the horizontal component of that. Okay, so we're going to use this formula in order to find time. X is equal to VI, initial velocity, cosine theta times time. Let's think about why that's written that way. Cosine of theta is going to allow me to find the adjacent side. Isn't that my horizontal component? It makes up part of my angle. The opposite side is going to be my velocity in the vertical direction. So let's rearrange this to solve for time. We can divide both sides by VI cosine theta. That gives us 1. Okay, so t is equal to x, my horizontal distance, divided by my initial velocity in the horizontal direction, VI cosine theta. Now, do I have the information to solve this? Well, I know that he has to go 4 meters. So I know the time required is going to be the 4 meters divided by his initial velocity of 5 times the cosine of 15. And when I put all of that into my calculator, I'm going to get that it takes 0.83 seconds. for him to make that jump. Now that I know the time, now I can use a different formula in order to find the y component. Another one of your formulas is y, or I think it's written delta y, is equal to vi sine theta. That's going to be my velocity in the vertical direction here, times my change in time, plus 1/2 times my acceleration. Isn't my acceleration going to be g times my time squared? Gee, that looks an awful lot like my free fall formula, doesn't it? So let's see what happens with my distance in the y direction. Five times the sine of 15 times my time, 0.83, that I found in the first part, plus 1/2 times 9.81 times 0.83 squared. When you put all that stuff in, and here's a helpful hint, if you're having trouble with your parentheses, do each piece individually, and that way you can solve it more easily and not get them so confused. So I think you'll find that when you do this, you get this. Now, I forgot to put my negative in here. We've got a negative for our acceleration because it's going down. So remember, we have to indicate direction on here. My y is going to be in the down direction. Okay, so when I solve this, I'm going to end up with negative 2.3 meters. And that negative is telling me that it's in this down direction. So it tells me that he ends up, after that period of time and jumping at that velocity, he's going to be at 2.3 meters, that spot in his jump. So that means he's going to make it and he's going to get across to the next building.